So we're going to take a few minutes and look at 5.2, which is solving quadratic equations by graphing, which is actually a fairly easy concept and something that we did a good bit in Algebra 1. In 5.1, we looked at graphing, and I'm just going to point out a couple of things here. If you have this trinomial equal to 0, which we just looked at the like f of x equal that. But if it's equal to 0, in other words, you want to know where the zeros are, you may remember from your Algebra 1 that zeros, roots, solutions, and x-intercepts are all kind of code for the same, primarily the same concept. But if we go back to what we did in 5.1, you may remember that we looked at the axis of symmetry, which is negative b over 2a. I didn't actually write the formula, but it's 3/2 in this case. And so if I'd done a better job with this graph, that'd been the axis of symmetry. So you can see I'm noting the vertex there. And so then when we graph that using this table over here, we graph it, we get a lot of different points that we can graph. But as we said, the zeros, roots, solutions, and x-intercepts are all the same. And so the zeros end up being here at -1 and +4. Now what we saw and we talked about in Algebra 1 is then x opposite sign the -1 is a factor, and x opposite sign of the +4 is a factor. So hopefully you see that these two things here are factors of the original trinomial. We just did factoring as a review. So hopefully you can see that the signs are different, and you could look at the factors of 4 whose difference is 3, be 1 and 4, and so that would work out that way. So there's a lot of information packed into that. What I just said is a ton of information and a lot of connections and things that we can look at and we can know. One last thing I'll say on this slide is when you look right here at these two zeros, they occur at -1 and 4, which is what we saw in here, which led us to understand these two factors. So that's what we're saying. We're saying we're going to solve equations by graphing. We're going to look at where the function, the trinomial, potential trinomial at least, is equal to 0. Where are the x-intercepts? Those are the solutions. And you can see a couple of my, there's 4 of them, roots, solutions, zeros, and x-intercepts. Are all primarily the same thing. They even tell you that roots are solutions and zeros are x-intercepts. So it's all kind of right there. So as we move along then, it says solve this by graphing. Solve this by graphing. Well, if I could start off, if I was going to graph it, I would write me some different x's and find out the y's so that I could do a table. But as we noted the other day, let's see, let me just do this. Let's see if I can do this. So, where this happens is important, because if it's way over here, you're going to need a bunch of negative x's. If it's way over here, you're going to need a bunch of positive x's. If it's kind of somewhere in here where you got a little positive, a little negative, then you need a little positive, a little negative. But how do you know? Well, the easiest way to know is to go back to the axis of symmetry. So if I look at negative b over 2a, there's b, so that's negative 6, and a is 1, so that's over 2, so it's at negative 3. There's a negative in there. It's at negative 3, which means the axis of symmetry is over here at negative 3. So I need to know what's going on at negative 3, negative 4, negative 5, negative 2, negative 1. And that kind of puts what I already know is the vertex here in the middle. Hopefully that is pretty clear to you, because pretty neat how that works. So when I put the negative 3 in here in the trinomial, put a negative 3 in for the x, then I get 9. Put negative 3 in here, I get minus 18 plus 8. I think we may have actually had this function in 5.1 that we did, same exact trinomial. But I believe that's a negative 1. So my vertex is right here at negative 3, negative 1. We'll see if I'm right here shortly. So negative 4, when I put the negative 4 in here, I get 16. Put the negative 4 in here, I get minus 24 plus 8, which happens to be 0. So that means this 0 is at negative 4. If I put the negative 2 in the trinomial, I get negative 2. Let me just mark those out. I get negative 2 squared, which is 4, and then 6 times negative 2, which is minus 12, plus 8, which is another 0. Now I could go on and find out the value for 5 and the value for negative 1, which, they're going to match, because those match, and there's your vertex in the middle. But you can see how that they mention here about the axis of symmetry, which is what we knew, and so we worked with that, and that's wonderful. Let's then talk about that graph. I've already got one, but I'm going to just kind of clean it up. So at negative 3, negative 1, and then at negative 4, and at negative 2 of the zeros. And I'm just going to mark that. It's at negative 4 and negative 2. So that the solutions to this trinomial are negative 4 and negative 2. So I could write it as a set with negative 4, negative 2. But I just have to really make sure we get this. So then the factors are x opposite sign the negative 4 and x opposite sign the negative 2, which are the factors. And we're not surprised, because we knew that the signs are going to be the same, and they're both going to be positive, and factors of 8 whose sum is 6. And man, it all fits so beautifully. You can see they got similar, because here's the vertex, and there's the matching, and there's the matching, and there's the zeros, because it happened at negative 4 and negative 2, and this is their matching graph. None of that surprises us, none of it whatsoever. If I'm going to look at this as solved by graphing, look, I can always come down here and pick these points and plug them in and see if they work and see if that works. And that's a shortcut way of doing it. But I'm going to do this. First of all, it opens up. So, no. Secondly, the axis of symmetry is negative b over 2a. This is just utilizing things that we learned in the first section. So b is 2, so that's negative 2, because it's the opposite of b. And a is 1, right? So that's just 2, so it's negative 1. So the axis of symmetry is going to be at negative 1. Dun-dun-dun-dun-dun. That's possible. Dun-dun-dun-dun-dun. That's not possible. Hey, it's a. It's a. It's what it is. I could do some other things to check this, to make sure that these points work and so on. But I will say that one of those zeros is at negative 2 and the other 0 is at positive 1. which even though they're not asking me, I'm telling us that then these are the factors. Remember, opposite sign of the zero. X, opposite sign of the two zeros. This, for us, works because the signs are different, and they are. And factors of 3 whose difference is 2. I think I can't count. That's a negative 3. So that's a positive 3. Sorry about that. I was looking at the axis of symmetry instead of the X or the Y axis. So anyway, so A is the answer. But it's just neat how all that works. Now, there's something that we should know, and when I was dragging that parabola around a while ago, I probably should have went ahead and mentioned it. But when we have a parabola that opens up, it could be up here above the line and never even intersect the line. And since that's where the zeros are found, that's why that is no solution. Or it could be down here and it can cross the line. And you can see there's two places where it crosses the x-axis. So that's why when it's like this, there are two real solutions, they call it. That. Then you have this other case where the vertex is actually on the x-axis, and that's this one here. And there's only one real solution. One real solution. Let me make a couple of notes for you about that. There's one real solution, but really it's a solution of duplicity. Duplicity. In other words, it's a duplicate. And the reason why it's a duplicate is because those are perfect trinomial squares. That's right. That's special. And that's how, if you see a graph comes down and the vertex is on the x-axis, then the trinomial was a perfect trinomial square. That's just how it works. But it's nice to be able to see that. So it says solve this by graphing, and here's one real solution. Solve this by graphing. Well, maybe you notice that it's not equal to 0. So the criteria that we discussed earlier is it has to be equal to 0. So I'm going to bring the minus 4 across to be a plus 4. Now, hopefully you recognize that as a perfect square just right away. That's a square, and that's twice their product. So that's going to be x minus 2 squared, right? X and 2 with the middle sign in the middle. So that means over here at positive 2 is where the vertex is going to be. It's where the solution is going to be. You probably can see right here that the y-intercept's at 4. And so the graph's going to come down here and go back up. So solve by graphing, 2. You're like, but I thought that was a negative 2 over here. Well, remember, it's x opposite sign. That's how those relate, is opposite sign. And the reason why, look, if you take that 2 and put it in for x, what do you get? 0. Yes, that's how it works. So they did something here, and they set it equal to 0 like we did. They did them a table. I did not do a table. I used other assets that we had. But again, we're able to see that that's how that works. So all of these, we kind of work similarly. We can do tables. We can look at axis of symmetry, like the one we did earlier. We can talk about opening up and down. You can see that these two open down. That's not possible because you can see that the leading coefficient is a positive. So they open up, the answer will open up, not open down. And if we set it equal to 0, we get x squared minus 6x plus 9 equals 0. And so my axis of symmetry is negative b over 2a, which is a positive 6 over 2, which is 3. So the axis of symmetry is at 3. And so the answer is A. And I should mention. And that's a perfect square, which is why there's one solution. Uh, let's take a little bit of time and talk about this little feller here. The instructions are kind of gone up here, but they want us to find two numbers whose sum is negative 15 and product is this. Sum is negative 15 and product is this. So would you agree that there's two things we don't know? We don't know the first number and we don't know the second number. Okay, for just a moment, I'm going to let it be x and y. I'm not really going to let it be x and y, but I want you to play the game with me for a second. I'm going to let it be x and y. And it says their sum is negative 15. So just help me write that. Their sum equal negative 15. Now, I don't want two different letters, okay? So what I want to do is it's just a trick, okay? So what I'm doing is a trick. I want to say y is equal to a negative x minus 15. And the reason why I did it this way is you would never see that for yourself. You would never see that the first one can be x and the second one would be a negative x minus 15. You just wouldn't see that. So I kind of tricked us here in doing this way. But it's a trick. That's what I'm saying. It's a trick. So I'm going to put my real definition of variables, and x is the first number. And the second number is negative x subtract 15. Okay. Then they tell us that the product of those two numbers is negative 54. So in other words, x times negative x subtract 15 is equal to negative 54. That's negative x minus 15x equal negative 54. If you don't mind, I'm going to make that equal to 0. Negative x squared plus, where'd it go? Minus 15x. Yeah, another one. And if I bring the 54 over, it's plus 54 and equal to 0. The reason I made that mistake twice right there is because I was thinking of what I was going to do next, and this is what it is. I'm going to, because I don't want to open down, although I can do the open down, but I'm going to multiply everything by negative so that it opens up. And so I get that. So if I graph this thing, it's going to be a monster because the y-intercept's at a negative 54. Negative 54 is the y-intercept. And the if I try to solve this by graphing, it's going to be kind of brutal, which is why I did what I did and why I would recommend to you that you think of this way. Leading coefficients 1, double bubble, x and x. Signs are different. Factors of 54 are 54, well, 1 and 54, 2 and 27, 3 and 18. Yeah, that's right. That's right. 4, believe it or not, doesn't work. 6 and 9. So when I read the map, I'm looking for factors of 54 whose difference is 15. Now here's a sum of 15, but here's a difference of 15. That's the one I want. So is it 3 minus 18 or 18 minus 3 to give me my positive 15? And so it's that. So stay with me. You probably had to back up and watch this again. I get that. So one of the zeros is at negative 18. The other zero is at positive 3. So if that's negative 18, then what happens if you put negative 18 in here? You get positive 18 minus 15, which is 3. So you see you kind of get both of them. Those are the two numbers. Whose sum is negative 15, think about it. Their sum is negative 15, their product is negative 54. That's a pretty good dance right there. That's a pretty good dance. And that's some significant work. Now I'm going to, that's a similar problem. So I'm going to drop down here, and I think this is the one that I want to just look at for a second. So this is estimate roots. Not everything's factorable. So not everything has integral solutions. Not everything can be done exact by graphing. In fact, it says here, if exact roots cannot be found. So we know they can't because they've already kind of given it away up here. But in a normal situation, we don't know till we know. And so I'm going to borrow their table for us to look at this. And I'm just going to make a note that when you see a change in y from negative to positive or positive to negative, then that's where the two zeros live. Somewhere between 0 and 1, somewhere between 3 and 4. Now this is an open down parabola. Watch, I want to show you the graph. And as I said, somewhere between 0 and 1, somewhere between 3 and 4. Now what I said? Yes. And we saw that, or we knew that, because when the signs change, it has, listen, when the y value changes from positive to negative or negative to positive, you had to cross the x-axis. So look at it here. When you went from negative y's, negative y's, negative y's to positive y's, you had to cross the x-axis. And when you come up through here and you've got positive y's, and then you got a negative y, you had to cross the x-axis. That's just how that works. So if you can get the graph, then you can see somewhere between 0 and 1, somewhere between 3 and 4. But if you don't have the graph, you got the table, because the table it gives it away. It's a beautiful giveaway. So even though we didn't get 0, like 0 for our y values, because that's what every x-intercept in the world has, is a 0 as the y. So that's why we're estimating, because we don't know exact. So there we are. So same kind of thing here. Solve by graphing. What are the consecutive integers between which the roots are located? So I want to play through this thing a little bit and see what we can get. So I could do a table of values, but really if I'm going to do a table, as I mentioned before, I need to know about the vertex. So when I do negative b over 2a, the opposite of b is positive 4, and the a is 1, so that's 2, so it's 2. So the axis of symmetry is over here at x equal 2. So if I do the 2 here, I plug the 2 in, I get, change my color for emphasis. If I put the 2 in here, x squared, that would be 4. Put the 2 in here, you get minus 8 plus 6. And that is positive 2. It doesn't look right. Where'd I get the 6 at? You may know. That's a 2. See? The 2. So that makes that, well, I'll just erase it. So that makes that a negative 2, and that's better. So that's my vertex here at 2, -2. So I'm going to try something like 1 and 0 and 3 and 4 for my x's, and then I'll find out the corresponding y's. First of all, I put 0 in, I get 2. So that's pretty easy. If I put 1 in here, I get, and mark those out, I get 1. Put 1 in for the linear x, I get -4 plus 2. And that would be, is that a -1? -1. So if I come back then and do the other two x's, 3 and 4, if I put in 3, that's 3 squared, which is 9, and put in a 3 here, it's -12 plus 2, and so I get a -1, which doesn't surprise me because I know those are going to match, and I know those are going to match, so I know that's going to be a 2. And I could check it if I wanted to be absolutely sure. But I want you to notice that you went from positive to negative here and negative to positive here, so that's going to be a dead giveaway to the fact that when I graph this thing, the zeros are going to be between 0 and 1 and between 3 and 4. So when I graph this thing with an intercept at 2, it's going to come down through here, go back up. If I had cute graph paper, I would see that somewhere between 0 and 1 and somewhere between 3 and 4, that's where the zeros are. So that was answer A.